So in part 2, we're going to tackle some more complicated problems. Now they look more complicated, yes, but you're going to go through the same 4-step process that you did in part 1. So don't be intimidated, just remember your 4 steps and take it one step at a time. Our first step is going to be to look for any greatest common factors. Well, I've got 5, 19, and 4, no greatest common factor there. 2, 13, and 20, no greatest common factor there. So there's nothing I can factor out. Next, we're going to factor any quadratics. Now, this is where these problems can get a little complicated. So to help you organize your thoughts and organize what you're doing, I want you to pay attention to this process. I want you to think of the numerator as one trinomial and the denominator as a separate trinomial. That works out nicely because they are separate. And you are going to separate them on your paper, and you can do this underneath. 5b squared plus 19b minus 4. That's my numerator. Okay, so I'm just bringing that down right here so I can work with it a little bit. And then we're going to take our orange one and we're going to bring it over to the side over here. 2b squared plus 13b plus 20. So I haven't done anything with them yet. I'm just separating them out so that I can work with them because we're going to have to factor these. And it's going to require us to use our little bouncy method or the X method, whatever works best for you. I'm going to go ahead and do these with the bouncy method. So 5 times negative 4 gives me negative 20. I need factors of negative 20 that add up to positive 19. One's going to be negative and one's going to be positive because that's the only way I'll get negative 20. So I know if I do negative 1 and positive 20, that combined will give me positive 19. So let's split that middle term. Minus 1b plus 20b, and the minus 4 stays there. So all I did was took this middle term and made it 2 separate things. Okay? Now we're going to factor by grouping. Group, factor out of 4 here. Oops, this should be 1. And then we have our twins and our loners. So our twins become a factor and our loners become a factor. Now that that's factored, I'm going to put that back in my numerator to go back up here to simplifying. So up here I'm going to put 5b minus 1 as a factor family and b plus 4 as a factor family. I factored my numerator and that's what it became. Now let's do the same thing for the denominator. 2 times 20 is, 40. Now it may take you a little while. You can go through all the factors of 40, but I happen to know that positive 5 and positive 8 will work. So I'm going to split my term. 2b squared stays the same. 13b is going to become positive 5b and positive 8b, and then my 20 at the end. Factor by grouping, and I can factor out a b, leaving me with 2b plus 5. Here I can factor out a 4, leaving me with 2b plus 5. And now I see I have my twins and my loners. So let me go ahead and put those together. I've got 2b plus 5 and b plus 4. So that's the factored version of the denominator. I'm going to go ahead and write that up top. 2b plus 5 and b plus 4. Now, all of these factor families are connected with parentheses or connected by multiplication. So I'm going to look to see if I have any identical ones, and I do. B plus 4 in the top, B plus 4 in the bottom, those will cancel each other out. So I'm left with factor family 5b minus 1 in the numerator and factor family 2b plus 5 in the denominator. There's nothing left to cancel because these b's, although they are identical, are safe inside a factor family. So we cannot cancel them out. We don't want to tear up that family. And we are done factoring number 5. Why don't you pause the video, tackle number 6, and come on back when you think you've got it. Okay, so my first step is going to be to factor out a greatest common factor. In the top I see I can factor out a 2. That leaves me with r squared plus 4r minus 5. In the denominator, 5, 20, 25, I can factor out a 5. That leaves me with r squared plus 4r minus 5. Now, after you factor out your greatest common factor, the next step is to factor any quadratics that you have. And we do have quadratics. We have a quadratic here, and we have a quadratic here. So we should need to factor those. But do you notice something? I hope you do. This quadratic in the numerator is exactly the same as the quadratic in the denominator. So even if I factor them, they're going to work out to have the exact same factors. And what do we do when the factors are the same in the top and the bottom? We cancel them out. So we don't even have to go through all that work of factoring these because they're going to cancel out. They're exactly the same. We can cancel them now and be done. So this works out to be 2 over 5. That is the simplified rational expression that started out looking so complicated. So don't get stressed. Take it one step at a time and you'll be just fine. Let's take a look at numbers 7 and 8. Okay, so the first step we're going to do is look for greatest common factors. 3, 17, and 10. No luck. 3, 15. I can take a 3 out of that. X squared x. I can take an x out of that. So our numerator is going to stay 3x squared minus 17x plus 10. There was no greatest common factor up top. But down here I can take out a 3x, and that leaves me with x minus 5. Cool. So now the only thing I have left to do is look for any quadratics to factor. I've got one. It's up in my numerator. So I'm going to take this down and give myself a little room to groove because I'm going to have to factor this quadratic by grouping. So 3 times 10 is 30, and I need factors of 30 that add up to 17. 15 and 2 will work. They'll both have to be negative. So negative 15, negative 2. I'm going to split this middle term. 3x squared stays the same, minus 15x minus 2x plus 10. Factor by grouping, and I've got 3x with an x minus 5 left, and negative 2 with an x minus 5 left. Be careful when you factor out a negative that you change your sign in the leftover, okay, because you've got a positive that you would have to divide by this negative. So that's going to change your sign. Now I've got my twins and my loners. And let's see, x minus 5 and 3x minus 2. All right, so that's my new numerator. X minus 5 times 3x minus 2. And I still have my 3x and x minus 5. Now I'm going to look for any identical factor families that I can cancel. And I see one right here. Cancel, cancel. I don't have any other identicals, so I'm left with 3x minus 2 in the numerator and just 3x in the denominator. And again, I cannot cancel this 3x and 3x because this one up top is safe inside a factor family, and we don't want to rip up that family. So we're going to leave him alone. Why don't you pause the video, see if you can tackle number 10. Come on back when you think you've got it. How'd you do? I told you, factoring quadratics is a big part of algebra, and it's one of those things that you're just going to have to become more and more comfortable with. So practice, practice, practice. You've got a few more on this page for you to practice factoring. If you run into any trouble or you have a hard time, please feel free to star it and bring it into class. Ask me a question. I'll be happy to help. Remember, greatest common factor, factor any quadratics, cancel any identicals, and reduce, and you should be in good shape. Thanks so much for watching. Have a great night.